I'm Danielle Amaro, a petrographer here at WJE's Janney Technical Center. When a client reaches out to us about a durability concern with their concrete, we will often perform a test and judge the water-cement ratio of the material. Today we're going to walk through examining a concrete core that comes from a deteriorated parking garage, where we'll judge the water-cement ratio in the near surface of the material versus deeper in the concrete. To begin, my colleague George is going to create a thin section that we will look at under the microscope to aid in determining the water-cement ratio of the concrete. And so now George is looking at a thin section under a polarized light microscope to look at the microstructure of the concrete. He's looking at things like the cement hydration, the spacing of the cement, and the paste porosity in order to help identify if the water-cement ratio is higher or lower. Now George is going to break a piece of concrete so we can examine a freshly fractured concrete surface. George is now looking at the freshly fractured concrete surface and using a hardness pick to get an idea about the relative hardness of the material. Concrete with a lower water-cement ratio is going to be harder than concrete with a higher water-cement ratio. Another test is putting a drop of water on the freshly fractured concrete surface. A lower water-cement ratio concrete is going to absorb water slower than concrete with a higher water-cement ratio. And so now that George has examined the freshly fractured concrete surface, we've determined that the water-cement ratio is elevated and that the near surface increase in water-cement ratio was due to the contractor adding additional water during finishing, creating a less durable concrete surface. Thank you for stopping by WJE's Janney Technical Center.